Hello everyone. In the next few days, we will be celebrating the release of .NET 10 and C# 14. In this video, I want to discuss the biggest feature in this release, extension members. This feature takes the classic extension methods to an entirely new level. I will walk you through all the details and show you the different ways you can extend your code. But first, let's revisit extension methods and what we had before C# 14. Extension methods allow you to add methods to existing types without creating a new derived type, recompiling the original type, and modifying the original type. They appear as if they were native members of the type being extended. Extension methods are static methods in static classes, but they are called as if they were instance methods on the extended type. The key is the this modifier on the first parameter. Let me show you an example. In here I have a static class, extensions, and some static methods. And as you can see, the first parameter has this modifier because I want to tell the compiler I want to extend this type. In here, for example, DateTime is my receiver type, and with toDateOnly method, I want to convert it to date only, or in the next method, convert it to the time only type. Extension methods works perfectly with generic types. We have is empty with generic of t, and this modifiers points to IEnumerable of t. Also ref and out are possible to use, and you can also add the generic constraints if you want. Let me show you how you can use them. You can easily call the extension method on your instance type. In here with the DateTime.now, you can call toDateOnly or toTimeOnly, and then there is another way to direct call extensions, the static class name, .toDateOnly, and your parameters. Definitely the first one is the type you want to extend. Also, this is same for swapref and is empty. I told you about instance members in extension methods, exactly like the list. We created an instance of list of int, and then is empty method appears. Let's talk about extension members. In C# 14, we have a new syntax, extension blocks. It supports multiple member types, and I believe it's cleaner and more organized approach. Before C# 14, we had this modifier on a static method parameters, as I showed you, but we don't need it anymore. And it was limited to instance extension methods, but we have more in this new feature. So extension blocks are capable to define multiple extension members in one block, extend a type or type instance, this is very cool, and support multiple member types. We had just methods, but now we have methods, properties, and operators. I want to emphasize on two extension types: instance extensions, extend an instance of the type, and static extensions, extend the type itself. Now let's dive into the code and see how we can convert old style to new one. Before we get started, you will need to make sure you have few things set up. First, you need to install the .NET 10 SDK. You can grab it from Microsoft website. Next, make sure you are using an updated version of Visual Studio or Rider so you can take advantage of these features. And finally, you might need to add a quick configuration to your project file, csproj. As you can see here, I have a target framework for .NET 10, but maybe you need one thing more. Lang version, set it to preview. Let's start by adding old style extensions just as I explained in the slides. I use underscores in the method names because we will be writing their counterparts in the new style. Now let's look at how we use them. Exactly same as slides I showed you before. Now it's time to convert them to the new extension blocks. First, we need to create a static class just like we did with extension methods. So as you can see, I have extension members, my static class, and inside it, I want to have an extension block. So I have written extension, parentheses, and this block. Now I want to convert one of my old style extensions to new one. As I said, for this new syntax, we don't need any this modifier. So we need to copy this type in here. Our receiver type in front of extension keyword without this. Now I can copy paste the whole method inside the block and change something. I don't need this part because it's moved here. I don't need a static because it's instance base member. Congratulations, we have our extension method or extension member with the new syntax. Now I can remove underscore. Let me exactly do the same with DateTime only. I copy paste it in here. I remove the receiver type because it's available here. Remove underscore and a static keyword. As I mentioned, you can create multiple extension blocks. So let's continue with this. Now I have another extension block and I just converted isEmpty to new version. So IEnumerable of T converted to IEnumerable of collection here, just different variable name. And because this is a generic, just like the other part of C#, you should define T as generic here with this syntax. Now I have a completely normal member. There is no static here and no needs extra parameters because just receiver moved to extension part. So we converted the old way to new way and we used generics. Now let me convert swap ref. Another extension block because my type changed. This is also generic. It accepts ref exactly same as extension methods. And in here you can define your generic constraint. We have an extra parameter, so we can just write it here. And the rest is just the body of the old code. Again, because this is an instance member, we don't need any static keyword for the method. So I think it's really easy to convert old version to the new one. As for usage and calling these methods, nothing has changed. I can simply remove the underscore I use in the old version and you will see they work perfectly. So let me remove them one by one, in here, and in here. The extensions change to extension members, so I need to replace it here. And as you can see, everything works just like before. So far so good, but up until now, we have only updated our old code with the new style. We haven't actually seen any new features yet. Let me go back to DateTime only and DateTime only. Wouldn't it be better to have properties instead of methods, something like DatePart and TimePart? That feels more natural to me. So let's write our first real new feature under the extension members category. Under extension DateTime, I want to add my properties. So these are instance properties, and as you can see, it's just like a normal properties. I have date part here, and I have a time part. You can use lambda version or classic version, doesn't matter. Maybe you ask yourself how we can use it. It is something like this: datetime.now and date part. Just like the other things, date, day, day of week, now we have date part and time part in here. It's good to mention, for direct call, we have a kind of a new syntax. You need your static class to start, but then for properties, you need to call them with this syntax. Lowercase of get, underline, and the name of your property. Everything I have shown you so far has been about extension instances. But I have mentioned multiple times that we have another new feature: extension types. Let me show you an old problem. Before this feature, if you wanted to extend classes like file, path, or directory in .NET, and because they are static by design, you couldn't extend them with the old extension methods. So we had to create another class with a helper or utils suffix exactly like this. So let me create a file helper. You can call it file utils or anything else. I want to have create file recursively. We have directory.createDirectory, and this method works well with recursive behaviors. For example, if you have nested directories and none of them exist, it can create them one by one. But for file.create, we don't have same feature. So I want to have file.create recursively. Before extension members, it's not possible. So I have a helper, and this is the method. I get directory name, and then if directory does not exist, I create them recursively. And I have override functionality. Based on that, I will decide about my file mode and create a file stream. Why I want to return file stream? Because file.create also returns file stream. So I want to have really a counterpart for that one. So developers would have to know or guess that this is related to a Microsoft base class, in this case file, and call it like this: file helper.createFile recursively. And this is the path I have. We know that file has its own create method. As you can see here, accept a string path and returns file stream. So wouldn't it be fantastic if we could extend the file class directly with a create recursively method that returns a file stream? That way, developers could find and use the method without needing to know about extra classes. Let's do this with extension blocks. So I have created a new extension block, and this time points to file, and it has no variable name here because I want to write a type extension just for this type, not the instance of it. And also this specific type is static. So I just copy pasted the method I had in file helper, and now I get file pass and override, same as before. And this method should be a static because I want to extend type itself. This is very important. You have static keyword here. And now you can use it and find it right under file static class, just like the standard create method. Let me show you how it's possible. So I will go for file dot, and then when I'm looking for create, I can see create recursively here. So easily with extension members, you can extend your static types too. The whole function call is something like this: file dot create recursively and the rest. So we have seen that extension members can extend static classes, but is it limited to static types, or can we do the same for non-static classes and add more static members? The good news is it's absolutely possible, and not just static methods, but statics properties too. Let's look at some examples. This time I want to extend a string type, but with type extensions. So I don't need any variable here. It's possible, but for this scenario, I don't need it. So I point to a string and just a string, and I want to have an extension member, a static member here. So I have has values, and has values accept a value a string, and I just check it shouldn't be null or white space. So for the usage, I can write something like this: a static member under a string type. But a string is not static, not like file or path or directory, but you can extend them easily. And for properties, you can write something like this: and a static property under double. Double.py or p already exists in the Microsoft library, but I want to have Euler's number e, the base of natural logarithms. So I defined a property which is static with this constant value. Let me show you how you can use it. When you come and call double dot, you can see also pi is here, and we have e. So we can have something like this, where e equals double dot e. This is really cool, isn't it? And the last feature I like to talk about, it is extending operator, which is a cool feature. Consider with division operator, I want to combine file paths. So under extension for string, I have created a static string operator, and for division operator, I have left and right, and I call paths.combine to combine the strings. And the usage is really funny. You can do something like this. To have a full path, you can just use division operator and combine all things together. I hope you now have a solid understanding of the new features that come with extension members and can start using them in your everyday programming. If you enjoyed the video, don't forget to like and subscribe. Take care and goodbye.